Hello, students. Today we're continuing to explore more methods to solve quadratic equations. Before that, I want to make a few comments on the two methods we learned before. The first method, the factor method. Now this method, later on you will find, is the most commonly used method. And the concept is based on the zero principle, so-called zero principle. I can change a quadratic equation into two linear equations and solve them separately. I think even though this method is very simple and very natural, you have to realize that since we know the nature of quadratic equations, or should I call quadratic polynomials, cannot always be factorized. You must have experienced that in S3. Some of them just cannot be factorized. So this method has some limitations. It cannot solve all the quadratic equations, not the ones that cannot be factorized. The second method we learned, called the graphical method. This method, the concept is a little bit difficult, in my opinion, because you need to understand how the graph is obtained. And then which feature you need to observe in order to get the roots. This is our final conclusion. If you have the graph, then the roots of the quadratic equation are the x-intercepts of the graph. This method also has some limitations. You may see, oh, first, the graph is not so easy to obtain. You always have to plot quite a lot of points in order to get this graph. Secondly, even if you can get the graph from computers or from calculators, you must realize that the roots you find through the x-intercepts are not exact values. Because they are obtained by measurements, we know there is always error in these if you use this kind of method. So I say that this method is difficult to perform, and also the answers are not exact. But this method, I believe, if you use it, you can solve all the quadratic equations. It doesn't have the limitation on which type I cannot solve. It doesn't have the same limitation as the factor method. Okay. Now today we are going to introduce the most powerful method. Using this method, you can solve all the quadratic equations. I mean, all. Doesn't matter whether or not factorized. And you don't have to plot any graphs. How do we achieve that? Look at the notes. The title is called Solving Quadratic Equations by Quadratic Formula. So today we're going to learn about this formula. Look at the first class activity. In this activity, you're going to solve 4 equations, all quadratic equations, by the method of taking square roots. Now, this method is not the factor method, it's not the graphical method. I just want you to realize that there are other methods that are available. Some of them are not in our textbook, but they are equally as simple. Okay, I will show you how to do that. A. You copy the equation and then you make a perfect square on the left and you leave the constant on the right hand side. And then you will take square roots. X equal root or negative. And then you can find the 2 answers. You simplify a little bit. And then you're done. Second one. You copy the equation. And this time it is a perfect square on the left. And on the right hand side, you have a number. You have a constant. And then you can take square roots. Okay. And then you can find 2 values for x. Now in this question, the 2 roots are irrational. Next, you copy the equation. And then you put a perfect square on the left, you put 28 on the right hand side, and then you take square roots. And then you can find 2 values for x. You may further simplify it, but it's not a must. I think in compulsory part, we can accept this answer. D. You copy the equation. And then you keep the perfect square on the left. And then you take square root. Okay. And then you will find 2x. And then you will find x. Okay. Now bear in mind that my last answer, this one, is not simplified. But in compulsory part, I don't think it's necessary because your final answer can be correct to 3/6. So in this case, you can use your calculator to find a decimal and write it here, okay? But if you're interested in simplifying the thirds, you can do that too as a practice yourself. Okay. Now, girls, I think you would have no problem understanding what I'm doing here. Basically, I'm just Basically, I successfully solved these quadratic equations, getting 2 roots each time, right? And the method is not that difficult. It's not that difficult. It's easy to remember and it's easy to perform. Most of the time, you don't even need a calculator. Now you may wonder, why isn't this method introduced in our textbook, right? Why shouldn't I learn this method first? Now let me tell you why. Although this method seems very good, it's very rare that you can apply it because it requires a perfect square on the left and a constant on the right. And not all quadratic equations can be written that way. Do you know what I mean? It always has a square, but also has something else in it, so that it's not always a perfect square and a constant. It's not always that. That's why this method you can use, but it's not introduced. However, this method, I think, is the basic of the quadratic formula. Now, what is the quadratic formula? You can look here. This is the quadratic formula, to be very simple. Now, if you have a quadratic equation and you know the 3 coefficients, A, B, C, A, B, C. Now, how to find the 2 roots? You just use this formula. It's very long, but I'll read it out. The 2 roots are negative b plus or minus square root b squared minus 4ac divided by 2a. You recite this formula the same way. Negative b plus or minus square root b squared minus 4ac divided by 2a. You say it a few times and you will be fine. Okay? Now inside this box, I'm going to show you how this formula is obtained. And later on, you can use it directly. To learn how a formula is obtained is a very important part in mathematics. You will try as hard as possible. Now, although I don't believe in the exams, you will be tested on how the formulas are obtained. The proof of the formula. I will copy the equation. I will put C on the right-hand side. I will divide A. Okay, I think so far you're fine. You copy, you move one term to the right, and then you divide A. Okay, now I'm going to add something. Sorry, I don't think I'm going to add something. I'm going to change this a little bit. Change this to x squared plus 2x times b over 2a. Now I am here rewriting b over a into 2 times b over 2a. It seems very strange why I do that. This is because I have some other things planned. In the next step, I'm going to add a term on the left. That is b over 2a squared. To balance the equation, I will add the same thing to the right. Here I will highlight the part I added on both sides, so you can see that these 2 values are just created. Now, since I have balanced both sides, the equation is not changed. The equation is still the same. Okay. Now I'm going to review my intention for doing all these things because I want to create a perfect square on the left and a constant on the right. Okay. Now I moved so many things and divide and adding, subtracting. I did all these to create a perfect square on the left. Now, how do I know it's a perfect square? It's x squared plus 2xy plus y squared. You see, it's a perfect square. So now it's a perfect square. Now I will solve the quadratic equation by taking square roots. You see, that's why I say taking square roots is the base of this formula. You must know this. So x plus b over 2a equal b squared minus 4ac divided by 2a, or negative b squared minus 4ac divided by 2a. Okay? Finally, I'm getting the value of x. X equal negative b over 2a plus b squared minus 4ac divided by 2a, or negative b over 2a minus b squared minus 4ac divided by 2a. Okay? Now, you see, now this root, I call it x1. So x1 is negative b plus this. The first root, I call it x1. The second root, I call it x2. Okay? Now, through, let me count. 1, 2, 3, 4, 5, 6, 7, 8. Now, through eight steps, we obtain the formula. If you can understand this process, that's great. If you cannot fully understand, maybe try a few times. Okay? Now I'm going to show you how to apply this formula. The applying part is very satisfying. Example 10. In this case, this quadratic formula, you know A equal 1, B equal negative 4, and C equal negative 5. You don't have to write this. You just need to bear in mind these are the coefficients. Now x equal to, you don't have to write x1, x2. You just write x equal to. These are the roots. That's negative b, okay, plus or minus b squared minus 4ac divided by 2a. And then you simplify. 4 plus or minus 16 plus 20 divided by 2. 4 plus 6 divided by 2, or 4 minus 6 divided by 2. 5, negative 1. Okay? Now remember, you don't have to write this, but you need to know what they are. In this question, A equals 6, B equals 7, C equals 2. So the two roots are -b plus or minus square root b squared minus 4ac divided by 2a. This one is 49 minus 48. 49 minus 48, 12. -7 plus 1 or -7 minus 1. And x equal to -1/2 or -2/3. You don't have to write this. Okay, isn't it very simple? Isn't it very simple? I think so, huh? As long as you know what A, B, C are, then there's no problem. Now, if you don't believe the answer, you can plug x equal 5 inside the equation to check out, to check, oh, are they equal? If they're equal, then these are the roots. Next example. In this case, a equal 5, b equal 6, c equal -7. So x equal -b plus or minus b squared minus 4ac divided by 2a. So x equal -6 plus or minus 36 plus 1 40 divided by 10. Okay, now this question, since 176 is not a square number, so the answer must be irrational. Irrational. So the question also asks you to leave the radical sign in the answer. So in this case, you must simplify the answer. Okay? Now this is to simplify the third. You have to also simplify the fraction. Okay? So the answer is in the third form and also simplified. Okay? Example 12. This equation, I cannot identify A, B, and C immediately. So I will copy the equation. I will move all the terms on the left. And to simplify my calculation, I will multiply 5 to the equation. This is because when I use the formula, I don't want to use fraction in it, as the formula itself is very complicated already. So in this case, A equal 25, B equal negative 10 root 2, and C equal 2. Now you don't have to write these. So X equal negative B plus or minus B squared minus 4AC divided by 2A. And then a bunch of simplifying. It's 10 root 2 plus or minus. This is 200 minus 250. Okay. And then you get X equal 10 root 2. Now plus or minus 0. Okay. Now you and I know plus or minus 0 does not change the value, right? So when you are hoping for two roots, this equation only has one root. But we call them repeated. We still regard them as two roots. It's just they are equal. Okay. Next question. Copy the equation. Expand. Move all the terms on the left. Make sure everything is correct. And then use the quadratic formula. Now here A, B, C are easy, so I don't write them out. Negative B plus or minus B squared minus 4AC divided by 2A. X equal negative 6 plus or minus 36 minus 180 divided by 10. X equal 10, negative 6 plus or minus negative 144. Okay. Now, up here, you will know that since you have square root a negative number, this answer will turn out to be imaginary, right? In that case, you will write no real roots. No real roots, right? No real roots. Don't write no roots. Write no real roots because it definitely will have an imaginary root, right? If you continue this, which is not necessary, but if you continue, you can find the two imaginary roots. Okay, but in our textbook, you don't have to find them. But you find them, it's not wrong. If you find them, it's not wrong. In fact, some questions do ask you to find the imaginary roots, but not all the time. Most of the time, you will stop here. You stop here, and then you're done. I think we've done this before. Remember, in the graphical method, sometimes the graph does not intersect the x-axis. Therefore, that equation does not have a solution. In this case, example 13, when you use the quadratic formula and after simplifying you get imaginary, that also means there are just no real numbers, any real number. They don't satisfy this equation. So there are no real roots. It's very strange because in the linear equations, I mean all the equation you solve in S1, in S2, and in S3, they all have solutions. They all have solutions. But with quadratic equations, sometimes they don't have real roots. They don't. That's all. That's all. If you have any question, you can ask me. See you next time.